Welcome to our short pitch of our paper, Can We Challenge Open Vocabulary Object Detectors with Generated Content in Street Scenes? This is a joint work of Osnabrück University and Aptiv. Open vocabulary object detectors are trained on large-scale dataset and therefore have seen a variety of data during training. However, their robustness and safety-critical driving scenarios is not well understood. Synthetic inpainting allows controlled insertion of unusual objects, and therefore this enables systematic probing of detector weaknesses. In our paper, we address two research questions. First, can synthetic inpainted objects in real street scenes challenge open vocabulary object detectors? And can we reveal systematic failure modes of these detectors? Therefore, we propose a synthetic inpainting pipeline. Starting with a scene, we can then crop an object of interest which we want to replace with an unusual or completely creative new object. To do this in a systematic way, we sample WordNet nouns and randomly sample 1 to n words, which we then concatenate to a hybrid prompt. We then, based on the crop and this prompt, ask an inpainting model to generate a complete new creature. This generated crop is then reinserted into the original data. Then, with this, we can generate complete new data sets where the scene is preserved, but we can insert unusual and completely unimaginable objects. We also look into single concept inpainting, where we ask ChatGPT to produce a list of objects unusual for street scenes. So here we look into more realistic, but also unusual objects for street scenes. Based on the single word prompt and the crop of an object which we want to replace, we can do the inpainting method in the same way. Based on the datasets we generated with our method, we evaluate multiple open vocabulary object detectors and also compare it to a classical baseline where we used faster RCNN. Here on the right side, we compare the AUPRC on lost and found, where we have the real data, the hybrid concept inpainting, and the single concept inpainting. We see a strong correlation of the AUPRC on real and inpainted data, so open vocabulary object detection detectors can be challenged by both real and synthetic data. Here we also see that grounding dyno remains the strongest overall the method, and that especially fast RCN has really low performance on this unusual and also on the real data. Now we found out that we can challenge the open vocabulary object detectors, but we are also interested in specific failure modes. So if we look into the AUPRC of grounding dyno and now compare different prompts, we see that the detection performance varies strongly. Even though the generic prompt object performs best, we see that small wording changes drastically and reduce the AUPRC. So for example, object on the street and obstacle on the street, which is nearly the same in terms of wording, already has a drastic influence on the performance. Another interesting thing we found out is that the model recall highly depends on the image locations. Based on our experiments, we found that some scenes seem to be easier than others, and so we investigated the location dependence a little bit in more depth. For that, we randomly sampled 2000 pixels from the road as bounding box centers and inpaint semantically varying objects all over the road area. And then we test the open vocabulary object detectors on varied inpainting objects at those random locations. By this, we found that the detection failures cluster at specific locations, and we find some blind spots independent of the object semantics. This can be seen by these heat maps, where we visualize the pixel-wise recall and the overlooked objects. So the key findings in our papers can be summarized that we propose a synthetic inpainting method, and we showed that the synthetic inpainted objects successfully stress test the open vocabulary object detectors. The most influent factors which we found were the prompt formulation for open vocabulary models, the scene context, and especially the object location. The object semantics, however, matter less than we expected. With this, we generated content which exposes systematic weaknesses in open vocabulary object detection and therefore can help to improve safety in autonomous driving. Thank you for your attention, and if you're interested in more projects, please check out our website osvia.org.